And thank you everybody for joining us for another one of the Siemens Cinemeric webinars. I'm your host, Chris Pollack, and I'll be joined today by a couple of guest presenters as well. So we're going to explore some different stuff over the typical operation and programming topics you usually see from my side. I think you guys are going to be pretty excited. So what we're going to look at is we're going to look at a company called Identify3D. They're actually a solution partner of ours, and they're making some great inroads into securing content and data in the digital manufacturing world. You know, as we all know, we're moving into digitalization, but it's a challenge at times. How do we secure our material? You know, this is all new worlds for us, all new roads. So we're going to be joined by Fabrizio De Pasquale. Fabrizio is the VP of Business Development and Strategic Accounts for Identify3D. Fabrizio is going to get the opportunity to go through some of the high-level features and functionalities that they've been doing that starts to answer some of these questions. And then after Fabrizio gets a chance to present, we're going to next bring in Daniel Moore. And Daniel Moore is the, Daniel's the Senior Programming Manager for Identify3D. And Daniel's going to get an opportunity to do a live presentation. So not only are we going to get to kind of see and talk about this on a high level, but we're going to get down in the trenches. You're going to see how it functions, kind of an end-to-end process. And then, as always, we're going to open up to Q&A at the end of the event. So any questions that come up through, feel free to type them into the Q&A panel as you think of them. And then in the end, we're going to get a chance to go through those. So without further ado, let me hand off over to Fabrizio, and I'll talk to everybody in a little bit.
Great. Thank you very much, Chris. And hi, everybody. It's Fabrizio De Pasquale speaking. As already mentioned, I'm in charge for business development and strategic account at Identify3D. And I'm going to give you a sort of introduction to what Identify3D is about, our product, our solution, and then finally hand it over to Daniel to go more into the details of actually how our solution works. Just to begin with, a couple of words on our company. So Identify3D is a startup. We're based in San Francisco, and we have a second office in Lexington, Kentucky. That's where actually Daniel is sitting right now. And we are around 20 people, 22 people, VC-backed, and we have a very close relationship with Siemens. So we are a partner of Siemens, soon to be an OEM partner of Siemens, meaning that our solution will be soon embedded in Siemens products. So let me get started here and talk about what our company is about. So we are, as the first slide says here, our goal is to enable the digital thread. So meaning the thread of data that starts with your CAD/CAM software, that is where you generate manufacturing data, and ends when a machine consumes this data. So, and when we look at this at the path that this data takes through your supply chain, what we want to do, we want to make sure that this data is protected, so we address security concern. We want to make sure that the manufacturing process, even if it's done maybe 1,000 miles away from where the data is generated, maybe years from now, will still respond to the initial specification, and therefore we introduce sort of the topic of quality and repeatability of the manufacturing process. The third element in our value proposition is traceability. So meaning that if you own that data, if that data is particularly important to you, you always want to know where this data is and who is doing what with this data, provided you have given the control on how the data is used. And so this is what we are addressing with Identify3D. And so we are going to show you exactly how that works. So now if we look more at the sort of more general trend in the industry, probably many of us are aware of the fact that what digitalization is bringing to the table, especially in the manufacturing industry. So if in the past we were used to actually first produce physical parts and then distribute them, store them, then distribute them again. This looks like a bit of a very sort of old way of doing things, meaning that this brings a lot of cost, a lot of let's say not flexible structure. What the industry as a whole is targeting today is more around moving the digital representation of parts, and therefore you manufacture closer to the point and time of use, and what you actually are moving around for most of the time at least is are files, is the digital assets. So, and this, as I was mentioning, obviously brings a lot of advantages in terms of having a much more flexible supply chain, eliminating inventory, no holding costs, so and really much let's say also closer and direct interaction with end customers who might, for instance, need spare parts within only a shorter time than usual, and you can still do it because you can produce much closer and much faster close to them. So and as I was saying, so in maybe location much further away or in time much shifted than what it is today. So obviously once we talk about the path of data between the engineering company that owns the data and the manufacturing, whether it is the internal manufacturer within a large organization or a supplier, then we come with a lot of challenges. So challenges related to first of all, who access to the data, so who has access to the data, what can be done with the data. If someone gets hold of this manufacturing data, they can maybe produce more parts than are supposed to be around that have been sold. There might be problems with regard to how the parts are made and therefore their physical properties, and then there are problems of in the end of liability when it comes to the owner of the data or the owner of the part that is being put in the marketplace. And or for instance problems related to now the data is running in a CNC machine. What happens if an operator make some changes to speed it up because he wants to it's Friday evening, he wants to go back home, and what happens to that part or to that machine, even if you want to protect that asset. So there's a lot of so what we understand here is really guaranteeing the integrity of the whole of the data as it's generated, as it moves through the supply chain, as it is consumed by a machine. And in the end, a machine, in our case, a subtractive machine that runs Cinematics. This is also something that applies to additive manufacturing, and we know Cinematics can be used for that as well. Good. So when it comes to our solution is made of several elements that sort of follow the existing workflow as it is today, from the engineering to the manufacturing. And let me spend a couple minutes here to briefly say, at least high level, what these different components do, and you will see exactly in the demo later on how you can actually work with these components. So the first one we call it Protect, and it's the one that is closest to your CAD/CAM software or additive manufacturing build processor, and it's a way to create what we call as a secure container, meaning that data, manufacturing data or process data that needs to be protected, they are encrypted in a container. And to manage, we generate also policies that define how the data is used. There are manufacturing policies where you, for instance, define the parameters that are to be enforced at machine level, as well as business-related rules, as for instance the number of parts that are licensed downstream, the type of machine, maybe an expiry date or a certification of a machine, a material that you want your part to be manufactured with. In the end, any kind of let's say data that is or configuration that is accessible at machine level, and in our case through Sinomeric, can constitute an element to define those rules, and that's something that we can give it. We can give it a certain range, or we can really freeze, for instance, all your feed rate, for instance, or all the parameters that you want to run with. At the other end of the spectrum, we have then Enforce, which is another piece of software that runs within Sinomeric in our case, and that is a piece of software that unencrypts the package and applies those policies that have been decided upfront. Further on, we can. So let me say something about trace before I go back to track. So when the packet, when the container is generated, when the policies are generated or are changed across the supply chain, because maybe you have an order, your supplier has an order, and then it subdivides the order to multiple supplier. This is also possible with our system. We keep track, and in the end, when a machine consumes the data and the part is produced, or maybe it's not, or maybe someone tries to produce more than what was allowed for, we keep track of that. So we keep track of each transaction in what we call trace. It's a database, or you can even put on blockchain if you really want to do blockchain. And that is where we keep track of all these transactions, and we have a full, let's say, digital history of the physical part that you will have in your hand. So, for instance, if you have a way, let's say you produce a part, you machine a part, and you are able to uniquely identify that part, maybe with a barcode or a QR code, we have the ability to scan that part and then retrieve the whole information, that the whole history of that part, down to the design revision that has generated the CAM data, for instance. And if you want to extend this traceability also to additional post-process steps, or even manual steps after the machine, or even a CMM, for instance, it's still a machine that runs with data and has certain constraints. We have what we call track, which is sort of an API or a way to collect additional data and or further, let's say, enforce a certain workflow after a machine has done its job. So this is really sort of high level, the different components, and obviously our goal is not to change anything in the way you are working today. So that means that all these components has to be paired to existing steps in today's workflows. So for instance, our protect element, the one that generates the package, can either run as standalone, or for instance, we have a partnership with Siemens. It's embedded in an XCAM, an XAM, or in a materialized build processor if you work with the additive. And as well as manage the element that manages the policies can be run locally, or can be run also in a PLM or in an ERP system. So meaning that once you generate the package, you can put the package in a sort of digital warehouse, whether it's a PLM system or an ERP system, and from there also generate licenses once you want to further send your package for production to your suppliers. And then when it comes to Enforce also, as I mentioned, is embedded in Sinomeric, but we have also other opportunities to make it run in parallel to, for instance, additive machine with additional industrial PCs. But that's not the focus of today. Today we focus on Sinomeric. So this is sort of high level what we are doing, how we do it in the details. That's the subject of the next presentation from my colleague Daniel, which is going to show you a live demo. One thing I want to highlight here, what you're going to see now is an X to Sinomeric demo. This is for us, it's easier to show you Siemens NX because we are embedded in Siemens NX. But as I was mentioning, our Protect element can also run a standalone if you use, for instance, SolidWorks or other software. Obviously, we're trying to be integrated as much as possible with all those softwares, but that works also as a standalone. And so with this, I hand it over to either Chris or Daniel. So Chris, you there?
Yeah, absolutely. Perfect, Fabrizio.
Okay.
That was great. So Daniel, I'm just going to give you your privileges now. So we're going to make you presenter, and you shall have it here in a second. I think everybody here is real anxious to start to see this stuff in action. But it was a great high-level presentation. Thank you, Fabrizio.
Thank you.
All right, Daniel, it looks like we got your screen. And let's see if we hear you.
Yep, I'm here. Okay,
perfect.
Thanks, Chris, Fabrizio. So, like Fabrizio said, I'll walk you through a full end-to-end demo here, starting within Siemens NX and ending at a Cinemeric control. So, I'll go ahead and get started here. So you can see I have a very complicated part here that I want to manufacture. So within NX, we have our Protect application up here on the toolbar. We actually have a couple of different types of integrations in the NX. One is where we have a plugin where we have the kind of the same look and feel as other applications within NX, so it has the same type of format. And we also have the ability to launch our standalone Protect application, and that's what I'll do for the demo. So I'll go ahead and launch Protect. And when Protect comes up, since we have this integration within NX, we're able to pull out information of the part and automatically load it within Protect. Come on, computer. There it goes. All right. So here's Protect. So basically, the Protect, you can see these tabs here. We kind of go through a workflow to set up our digital container, or what we call a DSI, which is short just for digital supply item. So the first tab here is defining the information on this part. So I'll give it a package name. So just give it something unique. And then I can give it a description if I want. So part to be manufactured. And this will follow this part throughout its digital life as we go down the supply chain. So now I can define what goes into this digital container. So this digital container contains two different sections. So there's the first section is a private section. So this is data that you want to protect. You want to control who has access to this data. So in this case, we were able to pull in the PRT file, the NX part file, as well as the G code that had been generated. So for this demo, I'm only concerned about the G code, so I'm going to remove the part file, and I'll send the G code downstream. And then the second section of this container is public information. So this is information that you don't care throughout the supply chain that anybody has access to. So this could be ordering instructions, and like in this case, it's just a simple picture of the part that's being manufactured. And so now I've defined what's going into my container. So now I need to define basically the business rules and how this part will be made. So in the manufacturing policy, I can select the type of machine that I want to manufacture this part on. So I'll select the device, and I have set up a Siemens, just a generic Siemens Cinemeric control for an 840D. And then now I can define the business policy, a license policy. So the purpose, so this is a production level part. I can define the expiration date. So I don't want this part to be made past the end of January. And I can also define how many of these parts I will allow someone to make. So in this case, I'm going to allow this part to be made 20 times. I can also add a serial number to each of those parts if I would like, and I'm going to actually assign a pattern to those serial numbers. And then I also can assign a breakage, and breakage is basically how we handle bad builds. So if something goes wrong during the middle of a build, we have different policies we can put in place on how that's handled. I'll leave that alone for now. So now I've defined my digital package, I've defined my license policy, and so now I'm ready to generate the license that'll go to manage, as well as the DSI that'll go to a digital asset storage. So I have this manage register called Monarch Manufacturing. I'll click export. It generates the license file. That license file goes up to manage, as I said, and then it'll generate the DSI. And the DSI is just an encrypted container. However you're getting your technical data package to your manufacturing floor today, it can travel the exact same path. So if you're putting that data back into Team Center, and if that's how you're transporting it, or if it's going to a shared network drive, it can follow the same path. We're not changing the user's workflow there. In the demo case, we have a digital asset stored, like a network drive mapped to where that data is going. So now I'm done with Protect, so I'll close out that. And I'll switch over to Manage. So in a typical situation, in the engineering and design phase, there will be an engineering manage running on that site, and then that manage could then license to a distributor that is running an instance of manage, and then that distributor license to a manage that's running at a manufacturing facility. For brevity of a demo, we basically go directly from engineering Protect to the manufacturing manage. So this is the front end for manage, so I'll go ahead and log in. So you can see here that the package we just created has shown up in Manage. So there's been no authorizations to be made on this part yet, and I'm authorized to make 20 of these parts. So now I'm on the manufacturing floor. I've got a part order in. I need to deliver these parts to a client. So I'll click Authorize. And so now I can select the specific Cinemeric device or Cinemeric-based machine that I want to manufacture this part on. So if you had on your shop floor 20 machines that had Cinemeric 840D controllers on them, you would have a list here, and if they were all running in force, you could select the specific one that you want to manufacture it on. So in this case, I only have one listed, so I'll select that device. Here I can also change the expiration date, but notice that I cannot set the expiration date past the date that was initially set in Protect. I can only restrict it. So say that I need, 4 weeks, the part 4 weeks before for some finishing or something, so I'll go ahead and pull the date in. I can also change the quantity here, but if I try to increase the quantity, so say I want to make 30 and I click Authorize, it does a validity check on the license to make sure that I haven't violated any of the initial policy that was set in Protect. And in this case, I tried to make more parts than was initially authorized, so I failed the authorized quantity check. So in this case, I'm only going to make one part, so I'll change the quantity to 1. And then since we're on an 840D controller, I have access to a few build parameters. So the build parameters are basically how we're going to allow the operator to run the machine. And in this case, we have just a simple example of fee rate override. And so I'm going to limit the operator to only run this part but with a fee rate override range between 80 and 110. And that's set. And I also have a policy that this is only going to run on a 6-axis machine. And my Sinutrain Cinemeric is set up as a 6-axis. So now I'll click Authorize. It'll do a validity check to make sure that I have not violated any of the initial license policy that was set in Protect. And then once that validity check is done, I should get green check marks. And so the status is good. It generates a sub-license. That sub-license is then sent to the controller. So now I'll switch over to Sinutrain. So we actually have an integration of our Enforce software running on the Cinemeric 840D, and this is the Sinutrain, which you're probably very familiar with. So what happens in Enforce is it basically goes off to manage every so often. It says, do you have a license for me? And as soon as it finds that license, it'll actually download the license. It'll then go and download the DSI file from a known location, and then it will create a job on the control. So that process usually takes a second or two, so we'll give it a minute. There it is. So now we have this new job under this map Identify3D folder, RGH package 5. So I'll just go ahead and open that real quick to show you the contents. So we actually haven't done anything with the underlying G-code yet. So the G-code is still encrypted, but we generate this header file that basically gives you information on the part. So the license policy that we had set. So it gives you the quantity, the expiration date that was set within Manage. If I'd set an authorized user, it would be shown here. And then it also shows the operator what the allowable range of the machine it can run on. So now I'll go ahead and click Execute to load this program. Yep. And so now the program is loaded. We still have not decrypted any G-code, but if I slide the feed rate override dial to something below 80, you can see that we post an alarm. And the alarm says feed rate override setting too low. The restricted date range is 80 to 110. And if I try to run the part program now, hit cycle start, it will prevent me from running the program. And as well as if I go above 110, the alarm shows again, and it will prevent me from running the program. So I have to run this program between 80 and 110 for the feed rate override. As soon as I slide that dial back within the allowable range, the alarm goes away. I can now hit cycle start. It decrypts the program and then allows the program to run. And so this part takes quite a bit of time to run, so I'm not going to let it run to completion just for brevity. But one thing while it's running, if I were to slide the feed rate override, again, out of range, it will actually stop the program and prevent me from restarting until I slide it back into the allowable range. I hit start, and it picks up where it left off and continues to run. So for brevity, I'll hit reset to stop the program. And now, since I've only authorized one part to be manufactured, and I've run that one part, it'll reload, but now I get a different header file that says no more quantity available. So if I even try to run this program again, I get an error saying no more quantity available. So I'll go and hit reset to clear everything out. And if I go back into Program Manager now, that particular job that was just created has been removed from the Program Manager, so I'm not allowed to run that program again. So what ties this all together now is trace. So we've gone through NX, Protect to Manage to Cinemeric. So now if I switch over to trace, log in here. I can see a complete history of everything we've just done. So if I slide down here to RGH package, I can tell when the distributor license was received, when that new sub-license was sent down to the manufacturing floor, when the private files was decrypted, and when the part was manufactured and the quantity was decremented. And so any points along the way where this digital asset flows through the system, we can capture data within trace. And as Fabrizio mentioned, This data could be in a central database, or it could also be stored on the blockchain if that's your preference. So that concludes the demo. So I'll go ahead and turn this over for any Q&A at this point.
Perfect. Great, Daniel. That was a great detailed overview, and I think we got a bunch of questions here. But again, to the audience, if you guys had any questions come up, either enter it into the Q&A panel or the chat window. Q&A might be the easiest for me, just looking at one central location. So let's start going through them, and I will throw this out to both you, Daniel, and certainly Fabrizio, if you want to unmute, if there's something that you'd rather jump in on, that would be great. One question came in, the attendee came in a little late during the presentation, so can we just get a quick high-level explanation again of the role of manage in the solution chain?
Sure, I can take that one. So manage is essentially a license server. Manage basically controls who has the rights to manufacture the part. So you can, manage has several different flavors depending on where you are in the supply chain. Excuse me. So it could be run on engineering and design, and in that case, it would allow that part to be licensed out to maybe a distributor or maybe directly to a manufacturing facility. And then in the distribution case, that manage could then be used to license down to another shop floor or actually to another distribution if there's a long supply chain. And then on the manufacturing side, manage is basically used to receive orders as well as assigning those orders to specific machines to be manufactured. Perfect.
Yeah, and this kind of, I think it was in conjunction with another one of our attendees' questions. He was just asking regarding manage, is it running just on the shop floor, or would it be both running in engineering or shop floor? So it sounded like, if I got from what you were just saying before, I guess there's different flavors, or at least the interface is going to look different depending on where you are in the process chain when you're looking at manage. Is that correct?
Somewhat. So the front-end view that we just showed, we kind of provide for folks that may or may not have their own ERP or MES systems. So manage ideally is running, it's a server application that's running kind of in the background ideally. So it can tie into ERP systems to where, say, you get an order in your ERP system for 10 parts, it would then go to manage and say, do I have the authority to make 10 of these parts? Manage would say, yes, here is the license to do so, and then the ERP system would then deliver that license. So manage, ideal in most typical scenarios, is kind of running in the background as a gatekeeper of how that design is used. But going back to your question, yes, it could be tied into an MES system on the shop floor. It could be on the ERP system at distribution. You know, there's different kind of flavors of it depending on where you are in the supply chain.
Gotcha. Now, Dave was asking, is there any government specs or approval? So I would assume he's probably thinking about, like, if you're dealing with ITAR-based restricted components.
Yeah,
sure. Okay, go ahead.
Oh no. So with our software, we can help, let's say, implement or be compliant to specific standards and regulations such as ITAR. Then we have to look at how each company goes about those processes and work with each company on how to, let's say, automate certain aspects of those implementation and then help make it much leaner and much more, let's say, in check when it comes to respect those regulations. So that's sort of a generic answer because we need to see how each company does that. But for sure, we can restrict access to certain parts to whoever is not allowed to. We can enforce specific workflows on or how a certain part has to be manufactured also beyond the machine. So it's a very flexible tool that can help also with those compliance processes.
So that actually kind of
And
ties in a little bit to a question I had.
Yes.
So when I was watching the process, obviously, in the live demo, Daniel did so great, and I saw the MPF file sitting in our local drive. Where is the actual part program file? Is that sitting in external memory? Is that downloaded into the Cinemeric, or is that strictly running from a secure external folder somewhere?
So
you don't really
the
see
MPF
that.
File, so the MPF file, or the part program that we encrypt within Protect, goes into a DSI package. And so that DSI, excuse me, is actually, and I can show you this real quick since I still have control here.
Yep.
Manage. So within Manage, we have, and this is kind of an add-on to Manage, just a digital asset store. So you can see here this RDH package. Have this DSI.
So the part program's inside of that package.
The part program is inside that package. So in the Cinemeric side, what Cinemeric does, or the Enforce does, is once it's got a license, it's downloaded the license from Manage, it will go and look at certain locations to pull down the DSI. And so once it's got the DSI and the license, and it basically creates a job at that point. If it goes through the DSI and recognizes the G code and says, all right, I have G code, here's a valid license, and once that part program is loaded and executed, that job is loaded and executed, it then does the decryption of the file.
So the part program itself at the end does actually enter into the Cinemeric control flow, or is it not?
Yeah, it gets fed into the control to be executed, yes.
Okay.
But it's never decrypted as a file on the system.
Gotcha. Interesting. And then when it was running, not to take all the questions, but when it was running, I didn't notice, but I might have missed it. Do I, at least as a user or an operator, see the G&M code program running through once it starts in auto?
Good question. So that's flexible. So by default, we hide the G code, and some of that depends on the level or version of what we can do in Siemens Operate. So I should have mentioned this at the outset. So Enforce runs on Cinemeric 4.7 and 4.8 in both the embedded and with Windows versions. But with our policy language and the licensing language, we can have it to where you could display the G code in the main part window if you wanted. So if an operator did want to see the G code and what was being executed, and the IP owner did not care that they had that visibility, you could set it to where the G code was visible. But by default, the G code is not visible.
Gotcha. Okay, so now we got a bunch more questions. I think we're stimulating a lot of the audience too. They're rolling in quicker than I can say them here, which is great. So Greg was asking, can anybody override the rules from the CNC side or only from the station they've been generating it on? And it's asking also the same as like number of parts. So I would assume, he's talking more, once the job's down, can anything be changed on the floor, or like if this is being pushed down from maybe your tier one that you're working for, would it have to be addressed to them there, or can they give you guys privileges at the manufacturing level to make changes like that?
Again, it's kind of a flexibility option on what the IP owner, how the initial person, the IP owner who protected the design initially sets it up, the policy. So they could have a strict policy where they're not going to allow the operator to, for whatever controls we have. So in this case, it was a simple control on feed rate override, but you can imagine if there's a ton of different controls on the machine and the controller itself that we could have access to and limit or monitor what an operator can do. So depending on what the IP owner wants in a specific location, we can either say, no, you can't change this value at all, or you can change it, but it's in this allowable range, or you're free to change this however you want. So if the manufacturer feels like they have to have control over a specific value, that's been locked down by the IP owner, then in that case they would have to go back to the IP owner or whoever generated that initial license policy to generate a new license to allow that setting to be manipulated.
Gotcha. And back to Dave's original question regarding the government specs and approval. He typed in a little more. That would allow this to work within a government facility. So yeah, I guess if we're selling into a government facility, do we have any government facilities, I guess, currently that you're using this process? And
we are working closely with a lot of government bodies. Yep.
Perfect.
Yeah,
Perfect.
And
so they're already some of those
that,
facilities are already adopting this. Sorry, Daniel, what was that?
Yeah, and I'll add on to that because pointing out the government's important because certainly there's some parts of the Department of Defense and so on that have very strict rules in terms of how files and data get into their machines. So our solution works both in the cloud, so manage in the cloud, and so on and so forth, or it could be locally deployed. And also, it can be totally air-gapped. So if you have a SCIF where it's a very limited access room and you're not allowing, anything into the room where you're manufacturing the parts, you could put the license file on a USB stick and the DSI on a USB stick, or whatever medium you're getting your G-code onto the machine today. It'd be the same mechanism, and then you could get it loaded onto the machine, and Enforce would go ahead and do the decryption there. So it's an important question because we do support air-gapped and we do support locally deployed systems.
Perfect. Gordon was asking us, how does this deal with non-conforming parts? So I'm assuming he's referring to, we're doing in-process checking of the part geometries out of tolerance or whatever. So is there ways to kind of handle that type of scenario? Because obviously if we set it to only produce 6 and the 4th part's out of spec, if it's only ever allowing 6, we'll never be able to provide that order. So is there any type of mechanism that can interrelate, like in-process checking, and then maybe open up the...
Yeah, so that I kind of glanced over it during Protect, but we have this concept of breakage, which would kind of fall underneath that category. And we kind of treat that in basically 3 different buckets. One is kind of our default, which is strict, which is if you want to make 10 parts, you get 10 tries to make 10 good parts. And if you need if you have breakage at that point, so, a part's out of spec because of a tool wear condition or something, you have to go back to whoever initiated that license to get a new license to make more parts. So that's kind of the first bucket. The second bucket is what we kind of call semi-trusted. So we basically grant you a percentage overage. So I'm going to grant Fabrizio to make 10 parts, but I'm going to give him a 20% overage. So now Fabrizio has 12 chances to make 10 good parts. And then the third is kind of a trusted mode. So in that case, I'm going to give Fabrizio a license to make 10 parts, but he can have as many tries as he needs to make 10 good parts. And if we have access to data where we can monitor the quality of the build or know that, all right, the build stopped before the end of the build, so we know it was a bad build, all that data gets logged back into Trace. So in the trusted case, if I granted Fabrizio 10, I go back and look into Trace as the IP owner, and I see that he made 50 parts, and they were all from, the data that was captured looked like they were good parts. I know then I can't trust Fabrizio anymore. So,
perfect. Perfect. No, that makes perfect sense. Now, leading off of that kind of stemmed another question. So in the manufacturing process, one of the things that we can do quite well in the Cinematic Control is we can interrupt an in-process program if we need to jump out to do any number of things. I want to clean some chips, do some quick inspections, whatnot, and then I can immediately move back into the part programming and continue running from the point I was at. In this type of kind of restricted environment, does the operator still have that capability? Can they kind of transition in and out of the part program, or once it's locked, I got to kind of run it to completion?
Great question, and I'll say yes and no. Again, it kind of goes back into the policy and how it's set up. Certainly, we could allow that to happen, but we could also enforce where we prevent that from happening. So it's just dependent on how the job and license is set up.
Wow, so you can go pretty deep in the detail of the policies and how much you want to allow an operator to do and not do.
It's very flexible.
Okay, let me browse through here. Got a few more questions we want to get to. Does the machine need to be online? That's a good point.
No, as I just mentioned, no, the machine does not have to be online. It can be air-gapped, and it still works the same way. However you're getting your files to the machine today, it's the same process. Instead of hand carrying over a G-code file, now you're hand carrying over a license and the BSI.
Here's another question that rolled in. Obviously, the demo was with NX. Are there any other CAM systems that you have a plug-in for? So I know you said you could run like a third-party solution, but they're obviously with NX. You did a great job with that plug-in.
Yeah, so we do have a proof of concept with Materialize Magics, and that's more on the additive side. We have had talks with other CAD/CAM vendors in terms of potential integrations, but NX is the only one on the CNC side that we have a plug-in with currently.
Yeah, we're working with others like Autodesk, for instance. Yeah.
Okay.
Yeah, the goal is to be as integrated as possible with existing CAM software.
Yeah. We don't want to change security is one of those things where if not done correctly, it gets way in the way, and then people don't use it. So our main goal is to try to be as integrated as possible into their existing workflow packages and workflow tools, so that it's not a hindrance into their day-to-day operations.
Perfect. It looks like we got one more question here. How do you price the product?
So the product, so as you have seen, there's several components, and each component is priced on a per month basis. Protect is on a per seat, because that goes along with the CAM software. Manage is on a per site, and whether it's on the design side or the manufacturing side, and Enforce is on a per machine basis, per machine per month. And in terms of how much it's priced, then I suggest we take it offline, and we are happy to discuss more of the details.
Makes perfect sense. Yeah, I stay as far away from the commercial side as I can. Okay. Well, I think I got everybody, but if I missed anybody, by all means, please feel free to reach out to Fabrizio, Daniel, or even myself. Their contact information is here on the screen. And again, I want to thank everybody for joining us. Hopefully you got a lot out of this. Looks like it's a very cool package, and it's certainly a unique way to integrate to the Cinemer control. So I want to thank you guys for presenting today. It was great having you as some guest presenters, and we look forward to maybe pushing more of this stuff out. So I hope to talk to you all again really soon. So with that being said, have a great holiday, and we'll talk to everybody soon. Thank you.
Yep.
Thank you.
Thanks, Chris, for this opportunity to present. Yep.
Absolutely. It was my pleasure.
Bye-bye.
Thanks, guys. We'll talk soon.